EOS pilot project is working with the community to set the framework and make recommendations for what the EOS should look like, the European Open Science Cloud should look like in the future. The next thing we're doing is the stakeholder event that's being held at the end of November, and then we're going to build our final recommendations and present those to the community in the last part of the project. EOS doesn't finish then. We have a whole load of new projects, and communities like the ASTERICS community can work with the EOS Hub project to introduce their services into the EOS. There are new projects which are working with S3 clusters, which the astronomy community is involved with. And I think more generally, as the European Open Science Cloud develops and there are more structures for consultation, there's been many opportunities for the astronomy community to participate. For example, the stakeholder event we're holding next month won't be the last. That series will continue, so there'll be plenty of opportunities for people to put their views forward and work together to build the European Open Science Cloud.
The objective of the project is to bring together 20 major research infrastructures of pan-European relevance to build together the European Open Science Cloud, and this means providing services for distributed computing, data management and data analytics, which are for community-specific needs. The challenge of EOS Hub is also to define policies and procedures which will allow these infrastructures to work in a more coordinated manner, and also to promote their services to be exploited by international user communities. We are contributing to the implementation of the European Open Science Cloud portal through our marketplace. It's one of the pillars and the main online catalogs where users will be able to discover services and providers to publish their own assets and services. I'm today here in Cambridge to meet the ASTERICS and OBELICS community to understand the synergies and what are the needs from astronomy and how we should shape together the implementation of the European Open Science Cloud so that it can provide useful data, analytics, software, which can be reused by astronomers worldwide. So I really look forward to have a long-lasting collaboration, also bridging these to Escape, the future project, to work together and really share expertise and efforts.
I work a lot on bringing machine learning tools into the analysis of ATLAS data. So we have a lot of extremely large-scale data problems. Accumulating enormous amounts of data and doing our best to learn about the structures of information within that data. Machine learning is helping us to do that in a way because machine learning allows us to exploit the data itself to learn the correlations and structures within that data without us having to engineer it ourselves. And so it gives us a new set of tools to exploit big data analysis for solving the future challenges at the LHC.
I think that machine learning could be a good tool for analyzing our data. In the past we used a standard data analysis technique, a very powerful data analysis technique, but recently we start moving to machine learning algorithm that can help us in identify better noise versus signal, in classify the gravitational wave signal, in reduction of the noise contribution. I think it is worth to continue to work with this technique to be updated to what is happening around in the world in other fields of interest where machine learning is successfully applied, and we plan to integrate more and more this technique in our standard data analysis pipeline.